All right, notes 4.6 are on the discriminant, and we talked a little bit in class about some observations that we made, and pretty much the biggest thing that we needed to notice from all of the things that were solved right here. Go ahead and take a look at it in detail if you weren't in class. But the biggest deal is that whatever is underneath the square root is what's going to tell us what kind of an answer we're going to get. So right here, when we had 0 under the square root, we had one answer. When we had 16 under the square root, we had two solutions or two answers. And if you notice, they were nice even answers. So they were actually rational answers. Okay, here we had a 53 under the square root right here, and we ended up getting two solutions as well. But this time, our two solutions were irrational. And in our last one right here, we had a negative value, which meant we had no solutions. So what's in common with the two solutions that we got here? What's in common is that the values are positive. When we had one solution, we had 0 under the square root, and then we had no solutions when we had a negative number under the square root. Okay, what observations have you made? The number of solutions depends on the value under the square root. And that value is called the discriminant. So the discriminant, if this all comes from the quadratic formula, right? So remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But the only thing that is underneath the square root is this b squared minus 4ac. So this is our discriminant. So our discriminant is equal to b squared minus 4ac. Just this part right here. Okay, so if d is greater than 0, so notice here we had d was greater than 0, then we ended up getting two roots, two solutions. So here we had d was greater than 0, we ended up getting two solutions, right? We got two solutions here, two solutions here. That will always happen. And the reason why that will always happen is because if we get a positive value here, then we have like a number plus the square root and then a number minus the square root, which would give us two different solutions. Regardless of whether when I square root the value, I get a nice, even, pretty number or I don't, I still get two different solutions. I get a positive value and I get a negative value, right? If d is equal to 0, then there is one solution. And the reason why is because when I take the square root of 0, I get 0. So if I do 6 plus 0 over 2 or 6 minus 0 over 2, they're still going to give us 6 over 2, which means that we get the exact same solution. So if d is equal to 0, then there is one root or one solution. And then if d is less than 0, for example, right here, I can't even take the square root of that value, which means that there are no roots. Okay? If d is a perfect square, though, so for example, right here, 16 is a perfect square. I can square root 16 evenly. I get numbers that are nice, pretty rational numbers, okay? Even if I get a fraction, it's still rational, okay? Like if I get 5/3, it's still a rational value, okay? And even 0 is a perfect square. Here I get one solution, but it's one nice, even, pretty rational value. So the roots are rational. If d is not a perfect square, then the roots are irrational. But this is only true for if d is greater than 0 or equal to 0. If d is less than 0, it doesn't even apply to this because you can't even take the square root to begin with to determine if it's rational or irrational. So this question right here says to determine the number, this should say, of real solutions there are to each of the following quadratic equations and if they are rational or irrational. So I'm going to do the same thing that I've always done. It has to be equal to 0 on one side. I'm going to say a equals, here I know a is 3, b is -6, and c is 2. But this time I don't have to do the whole x equals -b plus or minus the square root of all that stuff. All I have to do is just the b squared minus 4ac. So here the b squared is going to be -6 squared. And then I'm going to do minus 4 times a, which is 3, times c, which is 2. And when I do -6 squared, I get +36. And then when I multiply negative 4 by 3, I end up getting a negative 12 times 2 is a negative 24. 36 minus 24 is 12. So because the answer is 12, I have a positive answer. That means I'm going to have negative b plus the square root of 12 and then negative b minus the square root of 12, still all over 2a. But you notice here how the whole point of this is that you get two solutions. So therefore, there are two solutions. But because I cannot take the square root of 12 evenly, 12 is not a perfect square, I get two irrational solutions. Okay, so there's two because it is positive, and it's irrational because square root of 12 is not a perfect square. Okay, let's try this next one right here. Here I'm going to say that A is negative 3, B is negative 15, and C is negative 26. So let's go ahead and do this. Let's plug our information in. So the discriminant is b squared minus 4ac. So here I'm going to plug in all of that information right here. So b is negative 15. I'm going to square that negative 15 minus 4 times negative 3 times negative 26. Okay, so negative 15, when I square it, right here, is going to give me 225. And then I'm going to multiply negative 4 times negative 3, which is positive 12. And then I'm going to multiply that positive 12 by negative 26. And I get negative 312. Now when I do 225 minus 312, I get negative 87, which is not square rootable, which means that there are no solutions. So let's visually see what's going on here. So the first example that we did, if you look and see here, the roots there are two roots, but they are irrational. There's just no way that I can get these answers to be nice, even, pretty numbers that can't be written out without square roots. In our next example right here, if you notice, it opens down and the vertex is below the x-axis, which means that there are no roots at all. And that's why we got a negative value for our discriminant. So in this next one right here, I just want to say something really quickly. You are, if you don't like that this a value is a negative, and typically we usually don't, you are always welcome to move everything over to the other side. So here, if I add the negative 4x squared, I get positive 4x squared. If I add the 11x, I get positive 11x. And if I subtract the 3, I get 3. And then when I get rid of everything on the left side, I have nothing left over on that left side. So now I can go ahead and figure out what all of my values are. So A is 4, B is 11, and C is negative 3. Let's go ahead and do just the discriminant. D equals b squared minus 4 times A times C. So here, when I fill in that information here, the b value is an 11. So this is 11 squared minus 4 times negative 3. Okay, so 11 squared is 121, and then negative 4 times 4 is 16 times negative 4 times 4 is negative 16, and then negative 16 times negative 3 is positive 48. And when I add these together, I get 169, which is square rootable. I can take the square root of 169 and I get plus or minus 13. Okay, so this right here tells us that we get two answers, and our two answers are rational. They are rational values. So here we get two rational solutions. Okay, and actually let's go back to number 3 really quickly. I just want to say there are no solutions. We want to say there are no real solutions because technically there are some things called imaginary numbers. So we could technically solve this with imaginary numbers, but we don't have to worry about that in our class. All right, number 4, same exact thing. A equals 25, B equals negative 20, and C equals 4 right here. So when I do the discriminant, I'm going to say D equals B squared minus 4AC. I get D equals B squared minus 4 times A times C. Go ahead and fill in all of that information. So B is negative 20. I'm going to square that, and then I get 25 times 4 right here. And negative 20 squared is positive 400. Negative 4 times 25 is negative 100 times 4 gives me negative 400. So here I end up getting 0. And 0 is square rootable. But when I square root 0, I only get one answer. So we can say here that there is one real And the solution will have to be rational because this is a number that I can actually square root. The square root of 0 is 0. So there's one real rational solution. And this is our answer here. Okay, let's get a visual on both of these examples. So in our first example here, I guess I should say third example, where our roots are, we can see there are two roots and they are rational roots. -3 is a rational number. 0.25 is also a number that is rational. So this right here, we get two rational solutions. In this one right here, we can see that it crosses the x-axis one time, and it is also a number that is rational because 0.4 is a rational number. It's not this crazy wacky decimal that goes on forever without a pattern. So this right here shows us that these are our two solutions. And that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.